This last video for lesson 4, learning about inverse functions, we're going to look at a well-known formula and find its inverse. So, question I'll ask you is, what's it like outside? Well, it's November 4th, and yet it's a beautiful day, maybe 60 degrees out or something like that. Pretty crazy for November. We're going to check the Weather Channel to find out the actual current temperature for the city of Somers, where we are located. Pulling it up here, Somers weather right now feels like 60 degrees. Not bad for November 4th, I would say. So we'll just throw that in here. We got that it's 60 degrees out right now. Pretty amazing. Usually when we do this lesson, it's much, much colder. Now, we want to know what that temperature would be in degrees Celsius. Maybe we've got some friends here from Germany, or maybe our Asian students would like to know in numbers that would make more sense to them using the Celsius scale. To do that, we can use the temperature conversion formula, which you see over here. F, the Fahrenheit temperature, is equal to 9/5 times C, the Celsius temperature, plus 32. The only problem is, as I look at this formula, C Celsius is the input, and F Fahrenheit is the output. I want this formula to be the other way. I want to be able to plug in the Fahrenheit temperature and have Celsius be the output. Well, to do that, we'd be finding an inverse function. Now, when I have a formula where the variables are dedicated to a specific real-life thing, like F stands for Fahrenheit and C stands for Celsius, if I were to find the inverse, I would not switch the variables first. So normally when we do this with, x's and y's, let's say y equals x minus 2, I'd switch x and y because x is the variable that we typically associate with input no matter where it is, and y is typically associated with output. So we switch them and then solve for x. Alright, back from our fire drill, I switch x and y. X equals y minus 2, and then I add 2 to both sides, and I get y equals x plus 2. There's my inverse function because I had to switch x and y. So like we're saying, when we have a formula where the variables are dedicated to a particular real-life thing, like Fahrenheit and Celsius, I don't switch them, I just solve. I just want to get C by itself. So as I solve for C, so that I have an inverse function where C is the output and F is the input, I'd begin by subtracting 32 from both sides, which will leave me with F minus 32 is equal to 9/5 times C. And then to solve for C, I divide by 9/5. Well, dividing by a fraction is tricky, so instead I would multiply by the reciprocal. 5/9. When I multiply by the reciprocal, be careful, you got to put this in parentheses. We're multiplying the whole thing by 5/9. So that gets C all by itself. So in the end, C, the Celsius temperature, is equal to 5/9 times F, whatever the Fahrenheit temperature is, minus 32. You could also, I suppose, have Googled that and found that answer without solving, but why wouldn't we solve when it's so much fun to do? To use it, let's see, if 60 degrees is what I've got for the temperature outside in Fahrenheit, I take 60 minus 32, and that would be 28. And then, so we'll do 28. And then we're going to take 28 times 5/9 yet. Nothing to reduce here, so in this case we're going to just have to take the top times the top. So take 28 times 5, which is 140, and then divide that by 9, which will give us something like 15.5 or so. So it's 15.5. Repeating, we'll go 15.56 degrees Celsius. So 15 degrees Celsius is a nice balmy 60-degree day for us in Fahrenheit.